Welcome back. So, where does this water go after exiting the glacier? There are a few options. For example, that's actually a very nice image that can show you where an outburst flood could come from. You can have like ice dammed lakes that are kind of forming around the glacier. Yeah, so where does the water go after exiting the glacier? So there are mainly two configurations. Either there is some kind of lake in front of the glacier, or this water goes in some kind of stream and ends up somewhere, eventually in the ocean. And you can tell if a river is glacier fed based on its color, on its sediment content. If you have a lot of glacial sediment in the water, that can be a hint of glacier-fed stream. If you take Copper River, or if you take the Copper River, it's a very, very silty river. That's because there's a whole lot. There's really an incredible amount of glaciers that are feeding that river, and it's super, super silty. If you put your hand in that river, in a few seconds, you will feel you can take your hand out and you will have some kind of silt on your hand. That's actually a funny anecdote. Oh, not super funny, kind of sad for the fish, but so if you deep net in the Copper River, some salmons are kind of eroded by the water because there's so much silt that's just abrasing their skin away. It's kind of nasty. Another hint that a stream might be glacier fed is its variation throughout the day. Glaciers preferentially melt more in mid to late summer and during the day. So if you consider summer to start around May and ending in end of September, that's a very, very long summer. But let's say the melt season at least. We expect most of the melt in the middle or towards the end of the summer, like around middle of July and during August. So that's when you would have the most discharge, meaning that's when the glacier is melting the most, is outputting its water the most. And glacial streams kind of reflect this pattern. If you have a river, if you measure the discharge of a river over several months and it's fed by glaciers, you will see that its discharge will be bigger during the middle and the end of the summer. And now let's say you zoom into that and you look at a daily time scale, or even like finer than a day, hourly time scale, you will observe that, well, you would expect glaciers to melt the most during a hot summer day, during the day, and at night, this melting kind of decreases. And you can see that very clearly in glacier-fed streams. You have an increase of the discharge during the middle of the day, and then slows down as the night falls, and then kicks up again during the next day. So super interesting patterns. Yeah, this is just another example of a discharge record of a glacial stream. So is that one fed by a glacier? Well, I can give the answer away. But yes, because you have that clear daily pattern of increase of discharge during the day and then decrease at some point. So it's pretty nice. Now let's talk about differences in seasonal timing of runoff. So if you consider a river in the mountain, you are measuring its discharge. And let's say you're measuring the discharge of 3 different rivers. River C in red, River B in blue, and River A in purple. You see that they kind of, A and B have a peak of discharge that's happening at a different time. A has a peak of discharge in May, and B has a peak of discharge around July. C has kind of a peak of discharge in February, but it's not as important as the other. So out of these rivers, which one is not fed by any glaciers or snow? Which one is fed by only snow? And which one is kind of fed by both snow and glaciers? So to get the answer from that, you can think of when would I expect things to melt? Snow, look around yeah, you can pay attention to that this semester actually. When does the snow start to melt? When is it mostly gone? The answer is really early in the melt season. Around mid-April, it starts to like, I don't know, end of May. If you have remaining snow, it means you're pretty high altitude. So the snow melts pretty early on during the year. Ice on the other side and glaciers mostly melt during the middle of the summer. It's because not only they have snow on top of them that has to go away, but the ice is not melting as fast as the snow. So denser material. So the answer to that is the purple discharge is actually a snow-fed river. There's no ice involved because, as you can see, after May, the discharge kind of drops. And it really spikes during March, April, when the snow is melting a lot. Rhone Glacier, which is the river in blue, is fed by glaciers and snow. Glacier because, well, we have maximum peak discharge during the middle of summer, kind of slows down after August. And finally, the Seine, which is not really fed by anything, yeah, doesn't display any specific discharge. There are a lot of glaciers feeding that river, so you can't see any of these patterns. So yeah, that's something, try to remember that. Maybe that might be an exam question in that type. Quiz prep. Why does the amplitude of diurnal discharge increase? I'll leave you a few seconds to answer that. We already talked about that. So basically, the amplitude of diurnal discharge increases during the summer because you're melting the ice more and more, but also you're more efficient at draining the water. At the beginning of the melt season, the water is not that doesn't exit the glacier very efficiently. It can kind of stay there because of the distributed network, drainage network. It kind of loses its way in the glacier. It doesn't have a very specific forward path towards the exit. But as you build this network, as you channelize that drainage network, the water is being more and more efficiently drained from the glacier, which is why you have that increase of discharge throughout the summer. It doesn't mean necessarily that it always melts more at the end of the summer, but what always happens is that the water is more and more efficiently drained through the glacier as the melt season advances. And if we were to look at the velocities of the ice, that would be something different, actually. That would kind of be the opposite of that. We would expect faster ice velocities early on the melt season and kind of decreasing throughout the melt season because that drainage network is being channelized and lubricates the bed less efficiently. So there are a lot of concepts here. Don't hesitate to roll back over and over. The quiz prep questions will help with that, but there are a few concepts here, and those are really important. Yeah, and that's another one of the answer. Another way to complete that answer is that during early on in the melt season, you have snow and fern on top of the glacier that kind of acts as a sponge. So as I said, the water is less efficiently drained through the glacier. And as it melts, as that snow, that sponge basically disappears throughout the winter, throughout the summer, throughout the melt season, as soon as the water falls on the glacier or appears on the surface of the glacier, it goes through the glacier and exits the glacier much faster. To give an idea of like the magnitude of velocity, we are considering that if you drop some water on fern, it will move at a speed of like 0.5 meter per hour through the fern. But if you pour it on the glacier, it will be like meters per second. Yeah. And yeah, last quiz prep for that video. Which of the following is not a common characteristic of glacially fed streams? I'll leave you a few seconds. Okay, so the answer, not a common characteristic, sorry, of glacially fed streams. That's answer D, peak discharge in spring. That is, a peak discharge in spring would tell you that the glacier is mainly fed by snow and not ice. So sediment-rich water, yes, if it's glacier-fed. Large diurnal cycles, same thing, yes. And peak discharge water in late summer. Those are the three ways you can almost for sure say that a river is fed by a glacier. You can even see that from satellite pictures. Like if a rivers appear really muddy, yeah, you can bet there's some kind of glacier up there. And that's for the next video.